कर दिया है भाई, रिकॉर्डिंग ऑन कर दिया है। So what is work, power and energy? Okay? What are we going to study here? Well, this is just an extension of the set of tools that we have been developing to study the mechanics of point particle, right? Single point particle, that is what we are talking about. So in the first part, I told you how to describe the motion of a point particle. That was what we did in kinematics. So we developed the concepts of position vector, distance, displacement, uh, velocity, average velocity, instantaneous velocity, acceleration, and average acceleration. Right. So we developed all these concepts to describe the motion of a point particle. And then we studied how the motion of a point particle occurs. How, if point particle is subjected to forces, it will move, right? So if it is subjected to certain forces, then you can now easily write the equation F is equal to ma, and you can find out the acceleration, and then you can again predict what kind of motion will the will the object have. Okay? So this is the last tool that we are going to develop for the motion of point particles, the work energy theorem, which you have studied as uh, the conservation of energy. Right? We are going to go into more depth. We are going to learn that the definitions that you were introduced to in class 9th and 10th were uh, incomplete, okay, in the sense that they were complete at the level of class 9th and 10th, but at this level now, the definition is more comprehensive. Okay? And we are going to learn the meaning of the term work. That is what we are going to concentrate on today. Then we are going to learn the work energy theorem. Okay? And we are then going to learn the concept of potential energy. So this whole chapter is basically divided into three parts. First, we learn what is work. Then we learn the work energy theorem and its applications, how to apply the work energy theorem. And then finally, we learn the concept of potential energy. The concept of power is something that will not be very different from what you have already learned. Right? So lastly, we'll learn power. So just like in kinematics, even before I could start to discuss kinematics with you, I had to teach you new maths, right? Remember, मैंने आपको calculus पढ़ाया और vectors पढ़ाया था, and the reason was that the definition of velocity is dr by dt, right? Dr, where r is the position vector, divided by dt, where t is the time. So even to have a meaningful discussion on what velocity is mathematically, I needed to teach you the fundamentals of calculus and the fundamentals of vector algebra. once we had done that, then also it is very difficult for some of you to grasp what is velocity and what is acceleration, right? But I hope that over time it is getting more clear and more clear. So just like we need calculus and vector algebra for studying uh, uh, kinematics, we need a new kind of maths to describe work. Okay? And I'm going to teach you that today. This new kind of maths is basically based on what you have already learned in vectors and calculus. And therefore, it does not require that kind of time that we took for calculus and vectors. जो भी मेरे को मैथ्स नया मैथ्स पढ़ाना है, that will be over by the end of this class. So it turns out that in the world of mathematics, there is something called a single variable algebra. And corresponding to this, there is something called single variable calculus. Right? So these two guys, they are related to each other. I can give you an example. Single variable algebra. Y is equal to x square minus 5x plus 6. Right? Find x when y is equal to 0. This is an example. Single variable algebra. Right? This is what you have learned since class 6. Single variable calculus. Y is equal to x square minus 5x plus 6. Find dy by dx. This is what we have learned at the beginning of class 11. उसके बाद से there is something called multiple variable algebra. Corresponding to this, you have multiple variable calculus. Right? Now the things that I'm writing in blue, they are not included in your syllabus in class 12, maths. So you are never going to see this in the syllabus for 11th and 12th. However, in physics, you are going to see some multivariable algebra. Multivariable algebra is, I can give you again an example. Can anybody think of a multivariable equation that has been taught to you in physics? You already know. I know that you know at least one multivariable equation. नहीं. X minus y is equal to 5 is a single variable. One is dependent, one is independent. नहीं. PV is equal to nRT. ये पढ़ा है कि नहीं पढ़ा है? I'm sure ये पढ़ा होगा ना? PV is equal to nRT. Z is equal to x square. Z is equal to x square plus y square. ये multivariable algebra. Right? अब multivariable calculus कैसा होता है? I will not write down here because you don't know. And we are going to discuss this. Unfortunately, we are going to discuss multivariable algebra, but at the end of this chapter only, right? So this chapter is going to be maths heavy. And whatever we learn in this chapter, whatever maths we learn in this chapter, we will be using throughout physics. So we'll be using the maths that we learn here in fluid mechanics. We'll be using the maths that we learn here in in uh, electrostatics, in magnetism. Okay. Then we have vector algebra. And then we have vector calculus. Right? Now, vector algebra you study, and you will be studying vector algebra in maths class 12. So you will be better at vectors than I am, vector algebra, right? But vector calculus, you will not be studying. So I will always be better than you in vector calculus. Vector calculus, unfortunately, is required in our physics syllabus here. I will be teaching you vector calculus. In fact, that is what we'll be discussing today. So vector algebra is, I don't know, xi cap plus yj cap plus zk cap. And vector calculus has got, um, vector calculus has got, so just like here, you can have find dy by dx, or you can have find integral y dx. Right. So in multiple variable calculus, there is differentiation and there is integration. And in vector calculus also, there is differentiation and integration. But be warned that this differentiation and this integration is completely different. There may be similarities, but the integration and differentiation in vector calculus is completely different from the integration and differentiation in multivariable calculus in single variable calculus. There may be elements which may be common, right? But it is a completely different thing. So we are going to study this today. And then finally, you have the complex algebra, which you will be taught, or maybe you have already been taught, complex algebra, right? So here the example would be something like x plus iota y mod of this argument of z. ये पढ़ा है अभी नहीं पढ़ा है थोड़ा बहुत complex algebra maths में. If you have not yet studied in maths, there is a whole chapter of complex numbers that will be taught to you, and again you will be better at complex numbers than I am. However, there is something called complex algebra, as complex calculus as well, and this will not be taught. Okay? And we won't need complex calculus in physics also. So here also there is integration and differentiation. तो ये जो डिफरेंशिएशन है और यहाँ जो डिफरेंशिएशन है, they are all different. Okay? What do I mean by all different? This implies, or this means that all have different rules. All these processes of differentiation are defined in a different manner. Okay? There are elements which are common, of course. Differentiation का मतलब change, a study of change होता है. वो स्टडी ऑफ चेंज मल्टीपल वेरिएबल में भी होएगा, वेक्टर कैलकुलस में भी होएगा, कॉम्प्लेक्स में भी होएगा। इसी तरीके से जो इंटीग्रेशन का प्रोसेस है वो चारों में अलग होएगा, लेकिन जो सिंबल है इंटीग्रेशन वाला वो सेम रहेगा, फॉर एग्जांपल चारों, राइट? So there are elements which are same, there are elements which are different, but we have to always remember that these are the 8 branches of mathematics which are required actually for the understanding of physics. And if you go beyond our class 12 syllabus in the future, you will, when you go to engineering colleges, right? Then you will be taught these things that I have written in blue, right? They will become normal mathematics. They will become part of the normal mathematics course. Okay. So please don't have any presuppositions about it. Okay, you don't know anything about what I have written. Okay, please don't have any presuppositions कि नहीं ये तो वैसा होगा, इंटीग्रेशन बाय पार्ट्स तो कॉम्प्लेक्स होएगा। कॉम्प्लेक्स का मतलब कॉम्प्लेक्स नहीं है, कॉम्प्लेक्स का मतलब डिफिकल्ट नहीं है, कॉम्प्लेक्स का मतलब एक क्लास ऑफ नंबर्स होते हैं जिनको हम कॉम्प्लेक्स नंबर्स बोलते हैं, उनका अलजेब्रा कॉम्प्लेक्स अलजेब्रा कहलाएगा और उनका कैलकुलस कॉम्प्लेक्स कैलकुलस कहलाएगा। क्लास ऑफ नंबर्स होते हैं जिनको हम वेक्टर्स बोलते हैं। You have already been exposed to the fact that two vectors are they take part in addition, they take part in subtraction, they take part in multiplication, but the definition of addition, subtraction and multiplication is completely different from the addition, multiplication and subtraction that was defined for numbers. Okay, that is what we do in single variable algebra. Single variable algebra and vector algebra are completely different from each other. Similarly, single variable calculus and vector calculus will be completely different from each other. Ironically, it turns out that in vector calculus, differentiation is more difficult as compared to integration. Right? In single variable calculus, we saw that differentiation is relatively easy as compared to integration. But vector calculus में ये उल्टा हो जाता है, इसलिए मैं vector differentiation की बात ही नहीं करूँगा, मैं केवल vector integration की बात करूँगा. Okay? So please be absolutely clear in your minds that we are going to study a completely different kind of maths, which is called vector calculus, right? Or more specifically, it is called vector integration. Now, you may ask, यार ये क्या नाटक है, ये क्यों इतना maths? So there are two options for us. Really, there are two options for us, right? Option one is हम Facebook और Instagram पे वो जो लोग पोस्ट करते हैं ना, वो देखें कि आइंस्टाइन की शक्ल बन गई वहाँ पे और E = mc² लिखा है, और उसके बाद से एक आता है निकोला टेस्ला ने ये बोल दिया और वो कर दिया, फिर उसके बाद से फेनमैन के कोट्स आ जाते हैं, फिर उसके बाद से गैलेक्सी की फोटो आ जाती है, right? So one option is we can actually look at the photo of the galaxy and think, नहीं मेरे को तो मालूम है, मैं तो बस देख के ही सब बता दूंगा क्या होता है क्या नहीं होता है. Or the second option is that we can actually learn what is happening, right? And it is very difficult. The universe, the mechanics of the world around us is very, very complicated. It does not happen कि आपने 5 मीम देख लिया तो आपको फिजिक्स समझ में आ गया. So you need to have an exceptional grounding in mathematics to understand the concepts of physics. Right? The language of physics is mathematics, as I have said before. You pick up any textbook of physics, you will find that the first 2 chapters are always dedicated to maths. Okay? So again, if you don't understand this concept of vector integration that I am going to tell you today, then it will be very difficult for you to understand the concept of work. Okay. So let's start. And again, please clear your minds. Start with a clean slate. मैंने आपको बताया, मैंने आपको पहले भी बोला था कि वो मैं आपको वेक्टर एडिशन सब्ट्रैक्शन सिखाने जा रहा हूँ, और जो न्यूमेरिकल एडिशन सब्ट्रैक्शन है वो आपने सालों साल में सीखा है, बचपन से सीखा है और रट रट के सीखा है, तो वो एक तरीके से मन में हार्डवायर्ड हो गया है। सबके नहीं, कुछ कुछ लोगों के अभी भी एडिशन में कुछ कुछ लोग को प्रॉब्लम आती है, मल्टीप्लिकेशन में प्रॉब्लम आती है, राइट? व्हाट इज 13 17 जा, व्हाट इज 13 17 जा, 13 into 17, 13 into 17 कितना होता है? देखो सब लोग कैलकुलेटर पे लगे होंगे, कोई नहीं, कैलकुलेटर पे भी नहीं निकल रहा है। सो 13 into 17 91 होता है ना भैया, ऐसे ना करो। हाँ, ये देखो 3 आंसर आ चुके हैं मेरे पास। जो बिल्कुल सही आंसर दिया। हाँ 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 हाँ, मैं केवल एग्जांपल बोल रहा था, हो गया। आई एम सेइंग दैट numerical multiplication is something that you have learned over many years, whereas vector multiplication I taught you over the period of a month or so, right? So this is again new maths. It is based on old maths, but it will have its own characteristics. So please, with a clean mind, with a clean slate, let's start. Okay? Don't have any presuppositions or prejudices कि नहीं मेरे को तो ऐसा नहीं वैसा नहीं. So vector integration we are talking about, and there happens to be two types of vector integration. One is called the line integration, or I will call the line integral, and the other is called the surface integration or the surface integral. Now both are in our syllabus. Fortunately, surface integral we can differ for the moment. Surface integral we can see later on, because अभी हमको उसकी जरूरत नहीं है, बाद में जरूरत पड़ेगी, इलेक्ट्रोस्टैटिक्स में जरूरत पड़ेगी. तो we will leave this right now, right? We will leave this right now. Radhika, guess करो, guess. So we will leave this right now, and we will talk about the line integral. Okay. So first, I want to talk about the notation of the line integral. Okay. Yes, good. So notation of the line integral is like this: integration sign, and then we have f dot dl ri rf. Right. This is how you write a line integral. Okay. The letters are not important except one. Right. In fact, except none. So we can write this as like, we can write this like this also. It does not really matter. Letters don't matter. The thing that matters is that there is a dot product inside the integral. Okay? That is, so please don't get confused. Okay? Integration of d dt, which is equal to integration of the velocity vector, which is something like t I cap plus 3t j cap plus t square k cap, right? And यहाँ पे मैं लिख दूँ t I cap plus 3t j cap plus t square k cap dt, which is equal to t square by 2 I cap plus 3t square by 2 j cap plus t cube by 3 k cap. This is not vector calculus. Okay, this is not vector calculus. This is simple calculus carried out on vectors. Please don't get confused. What I'm saying, this is normal calculus. This is single variable calculus being carried out on a vector quantity. Okay, that can be done. That is not an issue, right? But vector calculus is something different. Vector calculus is something that I've written on top. Okay, so this is not a dot product. This is not a dot product. And since this is not a dot product, therefore this is not vector calculus. Okay? So let me just rub this out. So please never be confused. Okay? वेक्टर कैलकुलस इज व्हेन इंटीग्रेशन साइन के अंदर एक डॉट प्रोडक्ट आया है और वो डॉट प्रोडक्ट जो है वो दो चीजों का है. वो दो चीजें क्या हैं पहले मेरे को ये डिफाइन करना पड़ेगा, राइट? सो जस्ट वेट. अभी आप लिखो मत कुछ में. डोंट राइट. आई एम टेलिंग यू, डोंट हैव एनी प्रीसपोजिशन. आई कैन गारंटी that whatever you are thinking will be wrong. Okay? It's just like asking a kid in nursery कि भाई तू मैं तेरे को algebra सिखाने जा रहा हूँ, okay, and you expect that the kid will start to actually tell you what algebra is, right? That is not going to happen. So please don't have any presuppositions. You do not know how to carry this out. Okay, so listen to me, learn, and then we will have a discussion. So I have written the notation of the line integral, and I now want to discuss the individual terms. Okay? So this guy or these two guys is called a vector function. Okay? What is a vector function? I will tell you in a moment. These two guys, they are called line elements. What is a line element? I will tell you in a moment. Okay? These guys, okay, they are just like before, they are called the limits of integration. Right? Now, from normal integration, the only thing that is common, okay, is the limits of integration. Limits of integration का मतलब वही है जो पहले था. That is कि limit का मतलब है यहाँ से लेके यहाँ तक carry out करना है. मतलब सेम है, मेथड सेम नहीं है. It will not be that you carry out this integration. Okay? It will not be. So let me forewarn you. It will not be that you carry out this integration and then you, in the answer, place this and then place this and subtract. नहीं, ऐसा नहीं होने वाला. Does not work that way. Okay. Only thing is that these two guys, they are called the limits of integration. Okay, and that's it. Limits का मतलब है वही यहाँ से यहाँ तक इंटीग्रेशन कैरी आउट करना है, लेकिन जो मैथमेटिकल स्टेप हमारे नॉर्मल सिंगल वेरिएबल इंटीग्रेशन में था कि आंसर निकाल के और ये वैल्यू सब्स्टिट्यूट करिए, ये वैल्यू सब्स्टिट्यूट करिए और सब्ट्रैक्ट कर दीजिए, वो अब यहाँ नहीं होने वाला है. इट इज नॉट गोइंग टू हैपन. Chalo. So let's then start. Please take a screenshot because I will be referring to this again and again. Take a screenshot and I will move ahead. हो गया? Screenshot ले लिया सबने? Take a screenshot. So first, I want to answer the question, what is a vector function? ये वेक्टर फंक्शन क्या चीज? वेल, वेक्टर फंक्शन वो है जिसके ऊपर हम वेक्टर कैलकुलस कैरी आउट कर सकते हैं। वेक्टर फंक्शन वो है जिसका हम लाइन इंटीग्रल निकाल सकते हैं, राइट? ये लाइन इंटीग्रल आप किसी भी चीज का नहीं निकाल सकते हैं। ये लाइन इंटीग्रल एक वेक्टर फंक्शन का ही निकलेगा। ओके, नाउ व्हाट इज ए वेक्टर फंक्शन? Well, to answer what is a vector function, let's go back one step. Okay, so let me put this in a blue box. Let's go back one step, right? And let's ask, what is a function that we studied in single variable algebra, right? So in single variable algebra or calculus. So a function is basically a mathematical object which takes an input and gives you an output. So the word function should immediately in your mind invoke this diagram. Okay? Here is the function, there must be some input and there will be some output. So for example, y is equal to 3x square plus 2x plus 1. This thing is a mathematical, this thing is a function. What are the input it takes and what are the outputs? So the input is one number, right? That number may either be the value of x or it may be the value of y, does not matter. And the output is also a single number. So for example, x is equal to 0, y is equal to 1, right? Okay. Another example would be, I've painted myself in a corner, but another example would be y is equal to, I don't know, 10, then x is equal to something. You can work it out. It's solving a quadratic equation. So a function is essentially a mathematical object which has some structure, okay, and it takes an input and it gives you an output, and of course the output will depend on the structure of the function. Simple explanation. In exactly the same way, a vector function will take an input and give you an output. The input that the vector function takes, okay, may be 1 or 2 or 3 or 4 numbers. But this is not important. Input is not important in vector function. What is important is that the output will always be a vector quantity. Okay? And again, nothing better than an example to explain. F, okay, the vector F is equal to x square plus y square I cap plus z j cap plus y k cap. This is a vector function. So in this case, the inputs are going to be free, x, y, and z, 0, 0, 0. The output will be a vector that will be 0 I cap plus 0 j cap plus 0 k. 1, 1, 1. And the output will be 2 I cap plus j cap plus k cap. Okay? Another example of a vector function may be like this. V is equal to 3t I cap plus 4t j cap plus I don't know 5t square k cap. यहाँ पे इनपुट केवल t रहेगा और आउटपुट आपको ऐसे वेक्टर मिलेगा. But when we are talking about line integrals, okay, then the vector function must be or must have as an input the x, y, z coordinates. It can have time also, no problems. But as we will see, the time will not play a role in the vector integration, in the line integration. Okay, so I hope that everybody has understood what is a vector function. A vector function is nothing but, please take a screenshot. I'm going to the next slide. Please take a screenshot. So examples of vector functions. Number 1, f is equal to k x I cap plus y j cap plus z k cap upon x square plus y square plus z square raised to the power 3 by 2. Okay. कभी देखा है ये वेक्टर फंक्शन? Anybody has seen this? Anybody has seen this vector function? कभी देखा है ऐसा वेक्टर फंक्शन? नहीं देखा है? हाँ, z स्क्वायर. किसी ने नहीं देखा है? किसी ने तो देखा होगा भाई. नहीं, वेक्टर का डायरेक्शन थोड़ी ना ये होता है. नहीं नहीं, किसी ने नहीं. चलो देखो देखो, यहाँ पे पहले से देखा है वो मैं पहले बता रहा हूँ. ओके, देखो y x z, this is the position vector of a point having coordinates x, y, z. So can you tell me how to write? ये आपका है x axis, y axis, z Can you tell me how to write R? Anybody remember how to write R in terms of ijk? How to write R in terms of ijk? The position vector has been drawn from the origin to the coordinates to the point having coordinates xi cap plus yj cap plus z. मैंने आंसर ही बता दिया. और किसी को याद नहीं है, केवल अभिजीत को याद है. R is equal to xi cap plus yj cap plus zk cap. ये याद है ना सबको भाई? ये ठीक है, आलस में नहीं लिखा वो बात अलग है, बट ये सबको याद होना चाहिए, राइट? ऐसा क्यों है? क्योंकि ये जो वेक्टर है, दिस इज एक्चुअली लाइक दिस एंड this is xi cap, this is yj cap, this is zk cap, right? Okay. Now anybody can tell me what is the magnitude of this vector? What is the magnitude of this vector? What is the magnitude of this vector? नहीं याद है किसी को? Nobody remembers except Satyam. Sujit. हाँ. Good, Sharwa. Yes, good. Yes. हो गया. हाँ. Yes. भाई 3 कहाँ से आएगा? क्या कर रहा है? It is equal to root of x square plus y square plus z square. Right? Pythagoras है ना ये तो? We discussed this, right? This is just Pythagoras. Pythagoras in 3 dimensions. Can you now tell me what is the direction of this vector? Direction कैसे निकालते हैं? Good, Zoe. Anybody else? Very good, Satyam. Yes. Very good, Abhijit. Exactly. Yes. और किसी को याद है डायरेक्शन? शरवार, डायरेक्शन. डायरेक्शन क्या होगा? वेक्टर का डायरेक्शन क्या होता है? वेक्टर का डायरेक्शन इज वेक्टर का डायरेक्शन इज r upon magnitude of r. So will you agree with me that the direction of this vector will be xi cap plus yj cap plus zk cap divided by x square plus y square plus z square raised to the power 1 by 2. 3 by 2 ही लिखने जा रहा हूँ. 1 by 2. Will you agree with this? And if I want to write this in terms of r, if I want to write this guy in terms of r, then what should I do? ये ऊपर न्यूमरेटर में क्या है? न्यूमरेटर में क्या है? What is there in the numerator? k को छोड़ दिया जाएगा. Yes. So this is r, right? xi cap plus yj cap plus zk cap. और डिनोमिनेटर में क्या है? और डिनोमिनेटर में क्या है? नहीं, मैग्नीट्यूड ऑफ आर नहीं है. देखो क्या है, मैग्नीट्यूड ऑफ आर नहीं है. हाँ, यस, ऐसे लिख सकते हैं ना, मैग्नीट्यूड ऑफ आर क्यूब. राइट? Everybody agrees to this? So I don't want to write it like this. I want to write it as k divided by mod of r square into r upon mod of r. Can I do this? I hope this is not a problem. I hope this is not a problem. आया समझ में जो मैंने किया? मैंने केवल न्यूमरेटर में r क्यूब को r स्क्वायर इंटू r लिख दिया, राइट? और r जो है मैंने r वेक्टर के नीचे लिख दिया और r स्क्वायर मैंने k के नीचे लिख दिया. So this will be k divided by magnitude of r square r cap. Did you agree with this? I hope everybody is agreeing with this. Now comes the $1,000,000 question. ये क्या है? ये क्या है? और ये क्या है? Single word to describe the first green blob and a single word to describe the second green blob. Can you? नहीं, यूनिट वेक्टर तो दूसरा वाला है ना, पहला वाला क्या है? मैंने आपको वेरी गुड वेदांत, वेरी गुड. मैंने आपको अगर ये लिख के दिया, ये जो ये चीज है, इसमें ये क्या है और ये क्या है? Ultimately, what did we start with, right? I mean, what is this thing? क्या है ये? This is a vector quantity, right? This is a vector quantity. Very good, अभिजीत. ये वेक्टर क्वांटिटी को मैंने बस दूसरी तरीके से लिखा हुआ है ना. इस कॉम्प्लिकेटेड, वेरी गुड सत्यम, इस कॉम्प्लिकेटेड वेक्टर क्वांटिटी को मैंने इस तरीके से लिख दिया. तो ये ग्रीन में ये क्या चीज है और ये क्या चीज है? You remember I told you how to write. नहीं, these are not components. You remember I told you how to write a vector quantity. Ultimately, what is a vector quantity? Very good, Abhin. Yes. So ultimately, a vector quantity is nothing but magnitude. पता नहीं क्या जोहेब तू बोल रहा है, मेरे को तो समझ में नहीं आ रहा. Magnitude, and this guy is the direction. Right? Remember, any vector can be written as magnitude multiplied by direction. So k divided by mod of r square is the magnitude of the vector, and r cap is the direction of the vector. Please take a screenshot. I will be changing the slide now. Please take a screenshot. So the vector, this complicated object, हाँ तो सही बोला ना, बात सही बोला, बिल्कुल सही बोला. This vector, this complicated XYZ wala object, which you claim, all of you claim that you have never seen before, and really you have not seen it before, can also be expressed as k by mod of r square into r cap. Okay, I'm going to change the slide now. So if we have a charge here q1 and we have a charge here q2, both are positive charges. What is the force on charge q2? class 10th. What is the force on charge Q2? What is the force on charge Q2? K Q1 Q2 by R square. याद है ना, ये सबको याद होना चाहिए. I mean, this is not, मैं ऐसा नहीं है कि मैं कौन बनेगा करोड़पति का ऐसा क्वेश्चन पूछ लिया कि हाँ, तो फॉर्मूला ऑफ इलेक्ट्रोस्टैटिक क्या होता है, यही तो मैं पूछ रहा हूँ. इलेक्ट्रोस्टैटिक फोर्स का फॉर्मूला क्या होता है? K Q1 Q2 by R square. और डायरेक्शन क्या होएगा फोर्स का? फोर्स का डायरेक्शन क्या होएगा? फोर्स का डायरेक्शन क्या होएगा? रिपल्सिव या along the line connecting the charges? Definitely repulsive or attractive? Repulsive or attractive? राधिका लाइक चार्जेस हैं, मैंने एरो बना के रखी है. Repulsive or attractive? Like charges will repel. So what is the direction of this force? What is the direction of this force? Well, I can't say that the direction of this force is repulsive. I mean, again we are falling into the meme world. I need to be very accurate. I need to be very scientific. So what is the direction of the red arrow? Is the direction of the red arrow the same as the direction of the blue arrow? Is the direction of the red arrow the same as the direction of the blue arrow? The blue arrow, remember, is the arrow which is joining the two charges. If the direction of the red arrow is the same as the blue arrow, then the blue arrow has a direction of r cap. Therefore, the red arrow must also have a direction of r cap. Right? So this is equal to constant divided by mod of r square into r cap. Sorry. So I would like to ask again, have you seen this force? Have you seen this force? Yes, you have. Which force is it? Are you sure, Abhijit? अब देखो, another XYZ axis, another vector R. This time I have mass M1, mass M2. Okay, what is the force on M2? What is the force on M2? कितना फोर्स है M2 पे? M2 पे ग्रेविटेशनल फोर्स कितना है? जल्दी बताओ. ये न्यूटन ने 1600 समथिंग में वर्कआउट कर लिया था. हाँ, और क्या डायरेक्शन है फोर्स की? What is the force on M2 and what is the direction of force? Is it along R? What is the direction of force? Towards M1, yes, yes. So this must be the force and its value must be G M1 M2 by mod of R square. लेकिन इसका डायरेक्शन क्या है? इसका डायरेक्शन क्या है? No, it is not R cap. No, I'm sorry. नहीं. Very good. Yes. Blue arrow और red arrow के डायरेक्शन के बीच में क्या रिलेशन है अभी? Yes, very nice guy. Yes, minus R cap. So can I write this again as a negative constant by mod of r square into r cap? Have you seen this complicated expression? Have you seen this force before? Have you seen this force before? Yes, you have. This is what the electrostatic and the gravitational forces look like. And you have learned today that this is also a vector function, right? This is a vector function. What is the value of this force at 1 comma 1 comma 1? You can figure it out. Okay. What is the value of this force at 0 comma 0 comma 0? What is the value of this force at 0 comma 0 comma 0? What is the value of the undefined? Of course, if M1 and M2 both exist at the origin, तो आप मुझे gravitation force घंटा नहीं बता सकते हो. Not defined ही बोलोगे. उनके बीच का distance होएगा तभी आप मेरे को gravitational force बताओगे. तभी आप मेरे को electrostatic force बताओगे. Right? So this is the vector function of gravitational and electrostatic forces, right? So this is a vector function representing gravitational or electrostatic right? And let me assure you that all forces in this world, all forces can be expressed as a vector function. Okay, so let me please take a screenshot again. मैंने थोड़ा सा इसमें changes किए हैं. Okay, I'll go to the next slide now. So any vector function for line integrals will look like हाँ इसका भी स्क्रीनशॉट ले लो भैया जल्दी से. Take a screenshot. ये सबको समझ में आ रहा है ना? I mean, I hope that this is clear to everyone. क्योंकि मैं कोई अभी ज़्यादा टेक्निकलिटी अभी है नहीं इसमें. So it will look like f is equal to some function of x, y, z I cap plus some other function of x, y, z I cap, j cap, sorry, plus some other function of x, y, z k cap. See now this is multivariable algebra, right? And I'll show you how this works. So f is equal to x upon x square plus y square plus z square raised to the power 3 by 2 I cap plus y upon x square plus y square plus z square raised to the power 3 by 2 j cap plus z upon x square plus y square plus z square raised to the power 3 by 2. Right? You see, this quantity is a function of xyz. This quantity is a function of xyz. This quantity is a function of xyz. So any vector function for line integrals is going to look like this. I hope now the concept of vector function is clear. It will be something I cap, something j cap, something k cap, but this something will itself be a function of the xyz coordinates. All the three can be separate functions, they can be same functions, it does not matter. आया समझ में? Hello, hello, hello. And please write all this in your copy. Okay, write it. If you don't write it, then you don't learn it. ठीक है ना? मैं पूरा टाइम दे के रखूंगा, मैं स्लाइड चेंज ही नहीं करूंगा जब तक आप लोग लिख ना लो इसको. Please write this. हाँ हाँ कैसा भी हो सकता है, बट एक्स वाई जेड का होना चाहिए. आगे बढ़ते हैं. So next is what is a line element? So what is a line element? This is easy. It's not difficult at all. So a line element is an infinitesimally small displacement. So basically, you have the x, y, and z axis, and you are like standing at a point. So you decide to move along the x-axis by a very small amount. मैं थोड़ा लंबा बना रहा हूँ for visualization purposes. And then you decide to move along the y-axis by a very small amount. And then you decide to move along the z-axis by a very small amount. Right? Let me just redraw this, or at least the missing parts. Something like this. So the displacement is like this. This is the line element. Yes, exactly. Yes. So this line element, this is the line element, can be written as dl, or you can write it as dr. Right? Dr we have already seen. V is equal equal to dr by dt wala dr. So why have I drawn these three blue lines? Well, these three blue lines represent the three vectors dx, dy, and dz. So this means that dl or dr can always be written as dx I cap plus dy j cap plus dz k cap. आया समझ में? So if I were to write this vector function as fx I cap plus fy j cap plus fz k cap, where of course this quantity is the same as this quantity is the same as this quantity. ये मैं केवल एग्जांपल लिया है मैंने, ये इसकी वैल्यूज अलग भी हो सकती है, राइट? द वैल्यूज कैन बी डिफरेंट एज वेल. So if I can write f like this, then the line integral f dot dl can actually be written as fx I cap plus fy j cap plus fz k cap dot dl. But dl can be written as dx I cap plus dy j cap plus dz k cap. And you know how to carry out the dot product? याद है किसी को? ये dot product carry out करेंगे तो क्या होगा? How will I? What is the answer to this dot product? If this dot product is carried out, what do I get? Yes, yes. I cap नहीं आएगा पार्थ उसमें, dot product में गायब हो जाएगा. I नहीं आएगा सत्यम. fx dx plus fy dy plus fz dz. Now you may be thinking, अरे ये तो नाटक है, तो बड़ा आसान है, 3 इंटीग्रेशन हो गए. ये नॉर्मल इंटीग्रेशन है, बाय द वे. These are all normal integrations. So this, well, they are not normal, but still they are not line integrals. Fx dx plus fy dy plus fz dz. Can anybody see the problem here? Can you see the problem? Can anybody see the problem? Why this is not as simple as it looks? Can you see the problem? Why is it not as simple as it looks? नहीं नहीं. नहीं आ रहा है समझ में? Yes, good. Yes, yes, yes. Very good. Very good. Very nice. Got it in one. बहुत बढ़िया. Yes. Fx is not a function of x. It is a function of x, y, and z. How do you integrate that? You cannot. हालत खराब हो जाएगी. So this is what we are going to learn, guys. अब आज तो नहीं हो पाएगा, but tomorrow morning I will show you how to calculate Okay, so I have now defined all the terms here. सब कुछ यहाँ पे क्लियर हो गया है क्या होता है, इसको कैरी आउट कैसे किया जाता है, that I will show you. That I will show you in the next class. We will also use this, right? But I'll show you a different method, and we'll call this method 2. हाँ, हाँ, ये तो स्लाइड शेयर करना ही पड़ेगा, शाम तक करूँगा. चल, so I'll see you guys tomorrow morning, right? Please don't forget जो आज पढ़ाया है. कल I will show you how to calculate this integration. चल, okay. Bye bye. I will see you tomorrow morning.